is equal to that to the 1 over 20th power, which is 1.0750. Therefore, y, the yield rate, is 0.0750. This one was pretty basic, right? Do you have any questions? Next one. I have Anurag. This is right out of your homework also. Only a little twist compared to your homework. Anurag receives an annuity paying $1,500 at the beginning of each month for 20 years. Okay. Beginning of each month. Beginning. So I'll call that year 1, month 12. This is year 20, month 240. He wishes to replace it with an annuity that has the same term of 20 years and has only 2 payments each year. So this one has monthly payments. The first one had monthly payments. This one has only 6-month payments every 6 months. And when does it begin? Let's see. He wishes to replace it with an annuity that has the same term of 20 years and has only 2 payments each year, both at the beginning of the 6-month period. So he has a payment here, and he has a payment here. 0, 1, and then this continues. The P's continue. And here also he had 1,500, paying 1,500 at the beginning of every month. So 1,500, 1,500, and so forth. Okay, what do they want to know? How much should the payments be if the exchange is based on a nominal discount rate? Okay, so that's a pain. Of 12% payable quarterly. So I have to convert that to I, right? Because they're giving me D. They're giving me D4 over 4 is equal to 12% over 4, which is 0.03. So the quarterly rate, 3%. I can do my 1 plus I12 over 12 to the 12th power equals 1 minus D4 over 4 power. And solve that for I12 over 12, which is I monthly. That turns out to be 0.010205. So now I have a monthly rate. And then let's find an expression here. How much should the payments be if the exchange is based on a nominal discount rate? Blah, blah, blah. Okay, so can I equate just the first year of these two? I don't have to look at the rest because I could just look at these, where this 1,500 at time 11 would be the last payment. So can I just look at this first year and this first year? Give me an expression then. Or how about even less than that, right? I can just look at this period and this period. Yeah, both the present values are the same. So can you give me an expression? P equals what? Here, in this one, I have a payment of P at 0 and a payment of P at a half and a payment of P at 1 and a payment every 6 months, right? So I'm saying if I just look at these 6 months and these 6 months, I can set the present values equal because these repeat throughout. So can you give me an expression for P just looking at this piece?
P equals 1500 A angle 6.
See this? This payments start immediately.
Oh, and double.
Right. A double dot angle 6 at what rate? This rate. The monthly rate. 0.010205. That's it. Clean it up. 1500. 1 minus v to the n over d. So I monthly. 1 plus I monthly. It turns out to be 8775.75. You had a similar problem on your homework. Yes? Do you remember it? So you'll have one on your final just like this, only with a twist. It may not be discount, it may not be at the beginning. This one might be at the end, this one might be at the beginning, or this one might be at the end, that one might be at the beginning. Follow what I mean? What's your question?
This is a really silly question, but can you go over what it means to be being paid at the beginning of the year versus being paid at the end of the year? That always like confuses me.
So in this annuity, the first payment is immediately. In this annuity, the first payment is also immediately. I'm not sure what you mean by beginning or the end of the year. So let's say you purchase a annuity in January. If it's paying at the end of the month, you won't get your first payment until January 31 or February 1. Whereas if it's an annuity due, you will get your first payment January 1.
So like if the question says the annuity pays at the beginning of the month, so should my timeline at 0 have like a payment?
Yeah.
Okay.
Then you just do double dot if it's annuity due.
And if it says like it pays at the end of the month, I would have the first payment at time 1.
Then you don't, yeah.
Yeah. So let's make a twist on this problem, okay? What if this P didn't start here, but started at time a half? How would the expression change?
We would have to discount P to a half. So
Give me an expression.
So EV to the 1/2 would be equal to 1500 A double dot 6. Because wouldn't the present values of both going to be the same?
But this P would be the accumulated value of these, because if I'm looking just at the 6 months and the first payment doesn't happen here, the first payment happens at time half, couldn't I just say that P is the accumulated value of the six $1,500 payments?
Oh, okay.
You see? And then what? What's the expression? Careful now.
P equals 1500 as double dot.
Angle 6.
Okay, gotcha.
Right? Okay, now how about this one? All these P's remain the same, but this 1,500 doesn't begin here. It begins at time 1.
So then, would we do,
I only want to look at 6 months because that's all that's necessary, right?
so P would then be equal to just A regular dot, like P equals 1500 A 6,
A angle 6. Correct.
Oh,
You got it. Is everybody else okay with that? Let's go to the next one. J. J takes a 20-year loan. He borrows $150,000 to be paid back with level quarterly payments at the beginning of every quarter. Okay, so 1, 2, 3, 4. This is year 1 and quarter 4. and at the beginning, right? He borrows with level quarterly payments at the beginning of every year. Okay, so let's call it P. P, 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 and all the way through. The interest is charged on this loan at a nominal rate of interest of 12% convertible quarterly. Okay, so I4 over 4 equals 0.12 over 4, which is 0.03 per quarter. Immediately after the 18th payment, he decides to pay off the loan. So I'm here. 18. Decides to pay off the loan. But the 18th payment actually happens at OLB 7, actually happens at time 17, right? This is the 18th payment. But they're asking you for OLB 18. The question says find OLB 18, but it says immediately after the 18th payment, he decides to pay off the loan. So actually he's paying off the loan here. Because even though this is time 17, because his payments start at 0, at time 17 he would have made his 18th payment, right? But the question is not saying find OLB 17, it's saying find OLB 18. So how about I first find OLB 17 and then I use my recursive formula because I have BT equals BT minus 1, 1 plus I minus R of T, finished, right? So first let me go find OLB 17. Can I do that? How should I do? First I think payments, right? First I think I have to find P. So let's do that. 150,000 equals what? I'm sorry, I still don't know your name.
Fine. Abdul. So wouldn't it just be the present value of the 18 payments? So P
How many payments do you have?
18.
No. They're asking you for the OLB here, right? But to find P, that needs to be 150,000 needs to be the present value of all the P's, and your P's end here. That's your last P at time 79 quarters. And this is 240 quarters. You follow what I mean?
Yeah.
No, not 240. 80 quarters. So at the 79th quarter is your last P. So nothing to do with 18 right now. Can you find me P?
79 A double dot. I'm sorry, P A double dot. 79 A angle.
How many payments do you have?
79.
Pardon me?
Oh, 80. I'm sorry.
P A double dot angle 80. At what interest rate?
I-1/4.
Okay, which is 0.03. Equals 150,000. If I solve this equation, I can first find P, correct? Let's do it. So this is equal to P, 1 minus V to the 80 over 0.03 times 1.03 equals 150,000. This is going to give me P equals 4822.10. Okay, now I want OLB 17. Retrospective, prospective, let's do both. Let's start with prospective. If I'm standing at time 17, how many payments do I have left? I'm standing at time 17. The the payment has already been made at time 17. How many payments do I have left? 62. 62 because the last payment is not at 80. The last